Hello everybody, today we'll be solving the first double integral on this channel. Now this is a rather simple one compared to a lot of other more difficult ones. So how do we set up our bounds? How do we do double integrals? Well, this is the double integral. Right here is what we're being asked to integrate. And this is our region, aka our bounds. So it's saying that x is from 0 to 2 and y is from 0 to 3. So instead of dA, this is going to become dx dy or dy dx. Due to Fubini's theorem, you can switch the order of integration. So now, let's set up our integral. So the way this works, we're going to rewrite it, and we're going to choose what we want to integrate first and second. So what's in front determines what we integrate first. What's in the back determines what we integrate last. First, last. I'm going to do dx dy. So we're going to integrate dx dy, and the way the integrals work, well, if dx is here, this should be the integral with x bounds, and if dy is here, then the back integral should be the integral with y bounds. So above them I'm going to write x equals, representing the bounds, and to the more left side I'm going to write y equals. Now let's go back to our problem. X is between 0 and 2, right? This is what the region is basically telling us, our bounds. So x equals 0, x equals 2, and then y is going to equal 0, y is going to equal 3. So it's, when we integrate these things, it's sort of like the partial derivative concept. If we're integrating with respect to x here, we will treat y as a constant. So let's rewrite this integral from 0 to 3, and well, let's integrate this. What's the integral of x, right? The integral of x is x squared halves when with respect to x. Now what is the integral of y with respect to x? In derivatives, they decrease. In integrals, they increase. It's going to be y times x. Just like if you had the integral of 1, that would equal x, right? We just basically add an x to this thing. And remember, we were integrating with respect to x, so this is going to be from 0 to 2. Those bounds representing for x. So now let's evaluate this. It's kind of funny, right? We're evaluating an integral inside of an integral. So now we're going to plug in the 2. So it's going to become 2 squared divided by 2 plus y times 2. Remember, we're leaving the y because we were integrating with respect to x. We must plug in bounds with respect to x. And now this is the integral dy. If we plug in 0, then the whole right hand side is going to be 0, so I'm just neglecting it right now. This then becomes the integral from 0 to 3 of 2 plus 2y dy. Nice, this is like a normal integral, right? There's no other x variables or z variables that we have to worry about. It's literally just integrating with respect to y. So if we do that, we're going to get 2y plus y squared. You add 1 to the exponent, divide by the new exponent, right? Now let's plug in our bounds. 2 times 3 plus 3 squared, and this will give us 6 plus 9, which is 15. So this typically represents volume, or the mass of a straight wire. So you could say that this is the volume enclosed by that region over this surface, right? that's how you do a double integral. Thank you for watching.